In this venture of programming, we're going to look at how we can combine loops, arrays, and classes together to have multiple objects on screen. And that's going to give us a lot of flexibility as we work forward in our code. So to begin this, I am just going to start putting in some of the base code that we always use. So since we will be having multiple objects on screen, they will be moving around and animating as we do that. We will need all of our standard kind of accoutrements here where we have to establish our size. I'm not going to have a fancy background clear yet. I'll just do a standard one. With the start of this in place, now we can simply add to it where I'm going to make my class object so that I can work with it, and doing so I'll just make our new tab. This will be my critter, and again start with class, the name of the class, a couple returns, put in our closing curly brace. Now go back and I will have my properties, I'll have my constructor, and I will have my methods. Properties are the data about this object, constructors where it instantiates itself, and methods are the things it knows how to do. So our constructor should have some values associated with it. It always matches the name of the class when we work on it. So that's an important thing to keep in mind. Now for properties, we're going to have a x position, a y position, speed x, speed y, and a width and a height. And then I want each of my critters to have a different randomized color to their main body so we can just see their differentiation to it. In this instance of working with my class, I'm just going to position it at a random position. So I'll say random, we'll start it in 100, and then we'll grab the width of our sketch, subtract 100 from that. So it's going to appear somewhere on screen since our object is going to have a width smaller than 100 and a height smaller than 100, so that's going to allow it to always appear on screen when it begins. And we'll be doing the same thing for the y value, but now use height and take 100 away from that. Speed x will be random. We'll just go with our common -5, so we get a value somewhere between -5 and 5. It varies, it could be close to 0, it could be close to 5, positive or negative, so it could move fast, could move slow in some given direction. Getting my little error message because my shift key apparently didn't register when I did speed y. Now for our width, let's set our primary width at 50, and our height is equal to 50 as well, not 500. And now I want to establish a color is going to be equal to color, and we'll just use random 255, well, need parentheses, random 255, and finally random 255. So it gives me a random red, green, and blue component between 0 and 255, which is how we designate RGB color values. Finally, it's going to know how to do two things. One will be update, so it can update its position, check boundaries, etc. And then it will have a display method as well of controlling how it renders itself on screen. So these will be the two methods that we put into it. Not logging much to the console, so I'm just going to pull that down. We don't need to do that. So x is not equal to, plus equal to speed x, and y will be plus equal to speed y. Finally, we'll check our bounds. Now we need to add in another method. A couple parens after that, some curly brace action. So that helps get us all set up with what we're trying to do there. Now, we can say if my x is less than 0, we want to multiply it by speed x so it goes the other way. Now there's another thing we can do, because we also, when we hit the other side, the full width of our sketch, we want to bounce it back. Well, knowing that they're both doing the same thing, we can combine this. So we can say if x is less than 0, or, and the way we represent or in programming code is the pipe character, so two vertical lines. The pipe character is above the return or enter key on your keyboard, right below the delete key, so it's in between those two. You'll notice you have to use shift to access it. So get used to seeing it because it's a very common item. Well, not to W. They're close to each other on the keyboard. And now I can go speed x times equals minus 1. And I didn't put in my closing curly when I made that, so that's a big fail on my part because it kind of looked like there was one there. I'm like, wait, that's not working. We'll repeat this with y. So if y is less than 0, or, double pipe, or y is greater than height minus the height of our object, close parenthesis, curly brace, return twice, close curly brace. There we go. That's the proper way to do it. And now speed y times equals minus 1. Alright, we've finished up our critter here. So it's now, it knows what it wants to, oh no, we didn't. I was looking down, I'm like, hey, I'm at the end of my thing, but I never defined display. So I want to fill with my color, my random color, and I'm going to draw a body, x comma y comma w comma h. So that works out pretty well. If I want to add a few more parts to it, I could do that. This is just a main body. I'm going to just put some little legs coming down from it. So I'll draw a few more rectangles. This time I'll go X, and I want it to start at the bottom, so it would be Y plus my height. So then I know that this rectangle will be starting at the bottom, and I want it to be 10 pixels wide and 20 pixels, not 220 pixels tall. I'll draw a second leg. That was the left leg. Now the right leg is going to be at my x value all the way to the right, so that's W, but then back 10, because that's how wide I'm going to make it. It will have the same y starting point, so the y plus h, so that makes it draw it at the bottom, and then we'll make it the same size of 10 and 20. Now I might add some other things to it, but that's enough to get started with my primary critter there. And to verify things are working, I mean, I can run my code, but there's not a whole lot to see because my draw isn't doing anything. So let's go here and say critter C. And then C is equal to new critter, a couple parentheses, and finally C dot update, update, and C dot display. Now let's run it and see what we get. You can see we get my little guy running over here. Let's hit play again. You'll see he's in a new color, different speeds happening. Kind of feel like you need some eyes though, so it feels like it's missing. put a comment in. I should put in a few more probably, but I'll say Phil, he gets to have red eyes. So 255, comma 0, comma 0 will be full red because that means I'm turning red all the way up and green and blue all the way down. And now I'll just draw a circle. This time I'll draw the circle at x plus 10 and y plus 20. So I'm moving it in a little bit, moving it down a little bit, and I'll make it 5 pixels wide. Let's give him a second eye because he's not a cyclops, and this time it will be x plus w minus 10. So same kind of thing we did with the leg, because remember we're drawing, as we're drawing it, if we move in 10 from the left, we have to move back 10 from the right when we're trying to position it. But our y will be the same, y plus 20, and our size will be the same of 5. Now let's run this and see what it looks like. Now he's got little eyes there. Okay, I like that. That's better. So, well, I'll say done with the critter for now, but you might get motivated to add something else to it because, well, it just makes it a little bit more fun. We have one critter, but what would be really fun, and this is why we learned about loops and arrays, is let's make an array of critters. So I am going to comment these out because we don't need them, though we could copy paste them in if you are typing adverse, or you just make a lot of typos as you do it. So I will specify making an array of critters. So I use the class name critter, a couple square braces, and then I'll just call it critters. It's very common in programming that our array name matches the kind of thing that's contained in it. It's just the plural version. I've just put the S on it. And also notice we have the class name has a capital C, but my variable name, lowercase. These are all really common conventions. Now, if you find that too similar for you, that they match too closely, and you want to change that, that's fine. You can name your things differently if you come up with something that works for you. But I used to do that because I thought when they're so similar looking, I would get confused when I was coding. But over time, I grew to appreciate this because when I look at the name of the array, I know what kind of thing it contains. So if I have an array of numbers, I would call it numbers. If I had an array of names, I would call it names. It makes it easier. So this way I have critters, plural, is equal to new, capital C critter, and then I can put however many I want into it. We'll just start out with a meager 10. So I've now made an array of my critter object and I have put 10 in it. I'm going to populate it though using a loop. Because if I have 10 objects, I could go critter square bracket 0, close square bracket equals new critter, and do that for each one. But if I get 100 or 1,000, that really sucks. So instead now, let's use our for loop that we just learned about. And I say for, and I can go look over in my code that I left up on screen intentionally to remember what is the syntax for a for loop. So int I is equal to 0, semicolon. I is less than, and now I don't want to type in the word 10. I want to use the length of the array because if I change in my code how many things are in it, I don't want to have to change multiple things. I just want to change how many items are in the array, and everything else will keep singing and working. So I'll say critters.length. It's the same way that when I specify width and height, this allows me, if I change the size of my sketch, my code doesn't break. So if I make this smaller, things aren't happening off screen. If I make this bigger, I don't have all kinds of empty, unused space. So that's why we always try to reference things by a variable and assign the actual value to that in one location. But then we can reference it everywhere in our program, and it just makes everything much easier. So then I++, close parenthesis, curly brace, return twice, close or open, return twice, close parentheses. So now we have our curly brace or close curly brace. So now we're ready to do something with it, and now I'll just say critters square bracket I, remembering that we start at 0, so we can specify using that iterator, that counter, as which position in the array we want to put it, and just say new critter. That's it. I now have an array populated with 10 critters. If I want to see them do their magic on screen, well, I'll just be doing the same. And this is one time where if I was doing this for myself, I would have copy-pasted. But when you're first learning, I encourage you to type it out, even if you do get typos, because it's going to help you cement it in your brain. And what did I mistype on here? And this is where, as I'm looking, what did I miss? This is where copy pasting would have worked well for me. I forgot the I. I just said int, the data type, equals 0. It's like, but what int equals 0? So I have to say I there. That's much happier. So now critters I dot display and critters I. First one should be update, and then display. So we update it, then we display it on screen. Now if we run this, we'll see that we have 10. But if I just go in and now add a 0 and run it again, I have 100. If I add in another 0, I have 1,000. Very easily we were able to scale up our program by storing all of our class objects in an array and then iterating over that array. So we used a loop to populate the array, and then we use a loop to iterate over that array of those objects that we now put into it or populated into our array, and we can now call their methods one after another. Hopefully you see the power of this, the excitement of this, of how it can create some really fun dynamic programs. Good luck and have fun.